I gave you a blue 45, 45, 90 triangle. If our hypotenuse is 1, what are the legs? Radical 2 over 2. In order to get from hypotenuse to legs, we have to divide by radical 2. 1 over radical 2 has to be rationalized. Okay? Let's talk about our pink triangle. I gave you a pink 30, 60, 90 triangle. Our hypotenuse is 1. Okay? Hypotenuse, what is a short leg then? 1/2. It's half of it. Right? And then from short leg to long leg, we multiply by radical 3. So 1/2 times radical 3 is radical 3 over 2. Please make sure both sides of your triangles are labeled so that if we're flipping back and forth, we can see. Well, we'll solve the same ratios. So the radical 3 over 2 is always going to be across the 60. Okay, so we're going to take some time, and I mean some time, and we are going to fill out everything about the unit circle. Okay. Let's first start with not using our triangles. Okay, we're going to save those for in a couple minutes. But what I have up here, the unit circle is a circle with radius 1. Okay, that's why we call it the unit circle. Okay, that's also why I had you make your hypotenuses length 1. So those will always be a radius. Okay. So this is the center, 0, 0, all right? And our radius is 1, okay? We are going to fill out every special angle, both in degrees and radians, and then what the coordinate on the circle is, okay? So here we are at 0 degrees, which is, and you know what, I'm going to do this in a different color. Sorry. Very good. 0 degrees, which is 0 radians. If this is 0, 0, and we have a radius of 1, what would this coordinate be right here? Well, that would also be our, okay, we can fill that out too. We have 360 degrees, which is 2 pi. I'm talking about this coordinate. So we're on the coordinate plane. If this is the coordinate 0, 0, our radius is 1, what would the xy coordinate be? 1, 0. Okay. Let's go to this angle up here. What's the degree measure? 90, which is how many radians? Pi over 2. Okay. What would the xy coordinate here be? 0, 1. Okay. What we're filling out right now, these are called quadrantal angles because they're in between the quadrants. Okay. All right. How many degrees are we over here? 180 degrees, which is the same as how many radians? Pi. What would this coordinate be to the left of the center? -1, 0. Okay. And last but not least, how many degrees is down here? 270, which is the same as 3 pi over 2. And that coordinate would be what? 0, -1. These are the 4 easiest coordinates to remember. Okay? Left, right, up, down. You know how the coordinate plane works, okay? Being able to visualize these will help you when we go to evaluate sine, cosine, tangent, etc. of these quadrangle angles, okay? We're going to fill out the entire unit circle, and then I'm going to tell you how we use the unit circle to help us, okay? So those are the easy ones, okay? I'm going to give you a unit circle quiz more than once. These might be the ones you want to start filling in first because those are the easiest to remember, okay? All right, blue triangle, you got it? Okay. With your blue triangle, we're going to use this to help us fill out the 4 angles that are basically in the middle, okay? So let's start here. 45 degrees. If we change that to radians, and some of you may know this just off the top of your head, how many radians is 45 degrees? Pi over 4. Okay? If 90 degrees is pi over 2, half of 90 is 45, so half of pi over 2 is pi over 4. That would be a good way to think about it. Now, if we are traveling on the coordinate plane, I have an xy coordinate. We travel horizontal x and vertical y. Do you agree? How you learned to plot points way back in, when did you learn to plot points? 6th grade, 7th grade? Way a long time ago, right? Okay, so take your triangle and place it here. Okay, notice how it fits just nice and neat there. Okay, 1 is our hypotenuse, it's also our radius, and so make sure that 1 is matching up with the radius. And look at this. When we travel horizontally, we travel along this side, and when we travel vertically, we travel along this side. And so we travel right, radical 2 over 2, and then we travel up, radical 2 over 2. And so our coordinate would be radical 2 over 2, comma, radical 2 over 2. Yes?
So it's like the x part.
Well, we're going to get there, okay?
Remember that.
Yes. We'll get there. But yes, you are correct. All right. So now let's go over here. We can put our triangle here. And now we are 45 degrees away from the x-axis. Okay. We haven't officially talked about it yet, but we're going to use reference angles with our triangles. You guys have talked about reference angles. Okay. Reference angle is the acute angle that we travel from the x-axis, okay? It's always the x-axis. So we want this to sit on the x-axis. So we're 45 degrees away from the x-axis, which is 180. So how many degrees is 45 from 180? 135. Okay? In radians, we are pi over 4 away from pi. 3 pi over 4. Okay? I want you to really listen. Whoops, that's a 4. I want you to listen to how I say things because that's going to also help you remember these special numbers here. Okay, so if we have that radius of 1 along with our hypotenuse of 1, we have to travel to the left radical 2 over 2 and then up radical 2 over 2 to get to that coordinate. So that would mean we are at negative radical 2 over 2, comma radical 2 over 2. Since we had to travel left, it has to be negative for our x. Okay. All right. Let's put our triangle in the 4th quadrant, which means you're probably going to read some numbers upside down. That's okay. Now we are 45 degrees past 180. How many degrees would that be? 225. Okay. Let's think in radians. We are pi over 4 past pi. 4 is past 1. 5, 4. Okay. All right, and if we want to get to this coordinate right here, we have to travel left radical 2 over 2 and then down radical 2 over 2. And then some of you might already be doing this as we speak, but let's go to the fourth quadrant. Okay, we are 45 degrees away from 360. How many degrees is that? 315. In radians, we are pi over 4 away from 2 pi. Okay, so to get to that coordinate, we have to go right radical 2 over 2 and down radical 2 over 2. You see some patterns. Okay? Disregarding the sign value, as in positive, negative, what's true about those 4 coordinates in blue? The x's are all the same except a positive or a negative. The y's are all the same except a positive or a negative. Okay? Now in this case, x's and y's do have the same value. That's nice, and that'll help you to remember it a little bit easier also. But notice as we move from quadrant to quadrant, the negatives and positives just change based on where we are in the coordinate plane. All right. Pink triangle, you ready? We're going to start with 30 degrees. Okay, 30 degrees is right here. I think this is a calculation we did on Friday. 30 degrees is how many radians? Over 6. Okay, so make sure you have your 30 degrees here with your hypotenuse of 1 should be matching up with the radius of 1. And if that's the case, watch as we move to this this xy coordinate. We have to move right radical 3 over 2 and then up 1/2. Right? That's labeled on your triangle too. So we move right radical 3 over 2 and then up 1/2 on our triangle to get to that coordinate. Let's go over here. 30 degrees away from 180 would be how many degrees? 150. That's a nice calculation. Okay. Pi over 6 away from pi. 5 pi over 6. Okay. So if we have this matched up here, from 0, 0, if we follow our triangle, we have to move left radical 3 over 2 and up 1/2. So negative radical 3 over 2 comma 1/2 is our coordinate. All right. In the third quadrant, we are 30 degrees past 180. How many is that? 210. We are pi over 6 past pi. Which would be 7 pi over 6. All right. And if we have our radius matched up with our hypotenuse for their 30-degree angle, you can see that we move left radical 3 over 2 and down 1/2. Okay. In our fourth quadrant, if we are 30 degrees away from 360, how many degrees is that? if we are pi over 6 away from 2 pi, that would be 11 pi over 6. Okay? And without even putting your triangle up there, I bet you could figure out what the coordinate is. What's that coordinate going to be? Radical 3 over 2, negative 1/2. We have to travel right radical 3 over 2 and down 1/2 to get to that coordinate. Okay? Why do we kind of already know that? What is true about all of those xy coordinates disregarding the negatives and positives? Are the x's all the same? Are the y's all the same? Yeah, they just change the negatives and positives based on which quadrant they are in. Okay, but all the 30-degree reference angles, or all the pi over 6 reference angles, have the same coordinate. Okay, and notice how they have that symmetry. They're all the ones closest to the x-axis. Okay. All right. Last one. 60 degrees. 60 degrees is how many radians? Pi over 3. Okay. So if we put our 60-degree angle here at the center, to get to that coordinate, we now have to travel right 1/2 and up radical 3 over 2. We're using the same triangle to create this coordinate. So it should have some similarities to our 30-degree coordinate, right? What's the difference between the 30 and 60-degree coordinate? X and Y are flipped. So if you can remember one, you can remember the other. You just got to remember which one is which. Okay? All right, let's go here to the second quadrant. $60 degrees away from 180 is how many? 120. And if we're pi over 3 away from pi, what would that be? 2 pi over 3. Okay. So if we place the 60-degree coordinate here at the origin, to get to that coordinate, we have to go left 1/2 and up radical 3 over 2. In the third quadrant, we are 60 degrees past 180, which would be 240. Pi over 3 past pi. 4 pi over 3. Okay. And for that angle, we have to go left 1/2 and down radical 3 over 2. Last one, you ready? 60 degrees away from 360. Ah, that's like the nicest one, right? Pi over 3 away from 2 pi. 5 pi over 3. Okay, and you guessed it. We have to go right 1/2 and down radical 3 over 2. So our coordinate is positive 1/2, negative radical 3 over 2. So I want you to take a moment, and I want you to discuss the symmetry of the unit circle and anything that you notice that we have not talked about yet, or maybe that we're going to talk about. Okay, so just take about a minute or so and talk to your pod about some things that you notice about the unit circle.
Everything's about this.
All right, things you notice. Things you notice. Side 2, what you talk about? Okay, so you talked about how in the second quadrant the x's are negative, the y's are positive. Here in the third quadrant, x and y are both negative. And then here in the fourth quadrant, x is positive, y is negative. Okay, 5, what you talk about?
The symmetricality of it.
Okay, it's symmetric both ways, right? But I really like to point out the x-axis symmetry because that's what we have to really be careful with it as in terms of those reference angles. Okay, I color coordinated this for a reason, right? All of our 30-degree angles are in red, 45 in blue, 60 in green. So you can see how we fold those over the x-axis. They're going to match up as far as those xy coordinates disregarding the negative sign. Okay? 5-3, anything to add to that? No? Okay? All right. I want you to look at your triangles. Help me out here. This 45-degree angle, what is the sine of 45 degrees using this triangle? Opposite over hypotenuse. What's the sine of 45? Say that. Radical 2 over 2. Okay, everybody, help me out. Cosine adjacent over hypotenuse. I see those numbers up there, don't you? Okay. Are you wanting to tell me? Give me 1 minute, and then I will let you say it, I promise. 30 degrees. Opposite over hypotenuse. What's the sine of 30 degrees? 1/2. Cosine of 30 degrees. 60 degrees. The sine. Radical 3 over 2. The cosine of 60 degrees. Caleb, what is your observation?
The x-coordinate is the cosine of that angle, and then the y-coordinate is the sine of that angle.
Anybody else see that? Those numbers that we just talked about. On the unit circle, any xy coordinate is going to represent cosine, sine. And I'm going to use theta for my angle. So all of the x coordinates represent the cosine value at that particular angle. And all of the y coordinates represent the sine values at each of the angles. Caleb.
So put the tangent of the cosine divided by the sine, or the other way.
Okay, let's talk about it. And it may be better to look at in this triangle right here. If we're talking about the tangent of 30 degrees, we would want to do opposite over adjacent, correct? 1/2 over radical 3 over 2. Well, if we're taking this coordinate, 1/2 over radical 3 over 2 would be the y coordinate divided by the x coordinate. Do you agree? Okay, so if we want the tangent at any angle, we need to take y divided by x. Okay. Now, normally I'd probably write this on the whiteboard here, but since I'm recording your guys' class, I'm trying to fit everything so if somebody's watching at home, they can see it, okay? So you can write these things either on the front or on the back, or wherever you need to fit them, okay? On the front's probably better, the more you can see all together, okay? Now, what about our reciprocal functions? Okay, well that's what they are, they're reciprocals, right? How do we evaluate the cosecant? We take the reciprocal of what? Sine. So we just take the reciprocal of the y coordinate. How do we find secant? We take the reciprocal of what? Cosine. So we can just take the reciprocal of the x coordinate. Cotangent is the reciprocal of tangent, which means we can just take y over x and we can flip it over to x over y. Okay. How many of you have seen this? Your teacher talked about that last year. Chris?
That's saying which ones will be positive.
Okay, so if we focus on the three major trig functions, okay, the three original, right? These are the ones that are going to be positive. Now, the unit circle is really going to help us see why that is. Okay, the x-coordinate represents cosine, the y-coordinate represents sine, and the tangent is the ratio of them. All right, so here in the first quadrant, everything's positive. So they are all positive no matter what. I'm going to point out the positives, negatives are obviously what's left over, okay? Here in the second quadrant, since the y coordinates are positive, our sine is going to be positive. Since the x's are negative, then the cosine is going to be negative. And since tangent is a ratio of the two, tangent's going to be negative as well. Okay, so the S stands for sine. All right, in the third quadrant, both x and y are negative, which means cosine and sine are both negative. But what happens when you divide two negative numbers? Positive. So tangent is positive. Okay. And then in the fourth quadrant, since the x-coordinate is positive, cosine is positive. The y-coordinate is negative, which means sine is negative. And then that would make tangent negative since it is a ratio. Okay. What do we do with it? All right. So basically, this is your tool to remember these special angles and their values quickly. Okay. When you get to calculus, you will appreciate how quickly you can recall this information. All right, but let's just practice. Let's take the angle 5 pi over 6. Okay, that is right here. So if I ask you for the sine of 5 pi over 6, you're going to tell me 1/2 because that's the y coordinate. If I ask you for the cosine of 5 pi over 6, you're going to tell me negative radical 3 over 2 because that is the x coordinate. Okay, here's a fun one. The tangent. The tangent is going to be y divided by x. Okay? There's only going to be so many times you're going to have to make this calculation because eventually you're going to be able to remember what happens when you take 1/2 divided by radical 3 over 2. Okay? These 2's are going to cancel. We have 1 over radical 3. We can rationalize to negative radical 3 over 3. Okay? Then from there, if we want the cosecant, we can take the reciprocal of sine to be 2. If we want the secant, we can take the reciprocal of cosine, which we would then have to rationalize. Okay? And then the cotangent, you can think of this a couple different ways. You can either take the reciprocal of tangent, or you can take x divided by y to get your cotangent of negative radical 3. Okay. You are not going to have the unit circle in front of you for every quiz and test that you take. Our goal is for you to be able to visualize this so that when I ask you for the sine, cosine, tangent, etc. of 5 pi over 6, A, you don't have to draw a triangle. B, you can just recall what that coordinate is, and bam, 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 be able to give me the answers. Okay? Here's where it really gets nice. Can you click on the link? if I want to evaluate at pi over 2. If these are one you want to write down on the back, okay, these might be good things to write on the back of your unit circle just so you can kind of see what's happening here. Okay? Pi over 2, we can't draw a triangle to figure that out. Okay, well, we know information about the unit circle. So the sine of pi over 2, what is the y value of, what is the y coordinate at pi over 2? 1. The cosine of pi over 2, what's the x coordinate at pi over 2? 0. And then the tangent is y divided by x. 1 divided by 0. It's undefined. Okay, now be careful with this reciprocal functions. Okay, what's the reciprocal of 1? 1. So if the sine of pi over 2 is 1, then the cosecant of pi over 2 is also 1. Okay, but here's where we got to be careful. The cosine of pi over 2 is 0. What's the secant of pi over 2? It is undefined. If we take the reciprocal, that would technically be 1 divided by 0, right? The reciprocal is 1 divided by whatever you originally have. Okay, that's nice. Okay. Now, the cotangent of pi over 2, what would that be? It would be 0. Remember, cotangent is x divided by y, and so that actually is 0. So I want you to notice with our reciprocal functions, if you have a 0, the reciprocal is going to be undefined. If you have a function that's undefined, the reciprocal will be 0. Okay, the reciprocal of undefined is 0, which sounds kind of funny to say. Right? Now we're going to do another one. Okay, we're going to evaluate the 6 trig functions of 5 pi over 4. Okay, so at 5 pi over 4, our coordinate is negative radical 2 over 2, comma negative radical 2 over 2. Okay, the 45-degree angle ones, or the pi over 4 radian ones, those are the nice ones, because x and y, they have the same answer. Okay, so negative radical 2 over 2, negative radical 2 over 2. All right, here's something that's fun. If tangent is y divided by x, what is y divided by x? 1, right? If x and y are the same, when you divide them, you get 1. Okay? Yeah, they'll go through more work. All right? So do you think that's going to be the case for all of these blue ones up here, where when you take x divided by y, you're going to get 1 or negative 1? Okay? Now, when we take the reciprocal, if we take the reciprocal for the cosecant, we get negative 2 over radical 2. When we rationalize it, it becomes just negative radical 2. Nice thing here, if you do it for cosecant, secant has the same calculation. So secant and cosecant are both negative radical 2. And what's the cotangent of 5 pi over 4? 1, right? If the tangent is 1, the reciprocal is? Caleb.
So it's like every single time for 45 it did the exact same. Like cosine, tangent, cotangent.
The negatives are going to be different, right? So anytime you have a pi over 4 reference angle, yes, these are going to be your numbers, except the negatives are going to be in different places, right? If we had pi over 4, these would all be positive. If we had 3 pi over 4, then tangent would be negative, but sine would be positive. Okay? Same thing with like over here, when we did the 5 pi over 6. All of these numbers are going to be the same with whatever pi over 6 you look at. It's just the negatives that are going to change. Okay? So we need to be able to use the unit circle to evaluate anywhere. All right? So tonight you have book work where you are going to practice using your unit circle to evaluate. Now, tonight you're going to use your unit circle the whole time, and that's okay. But you need to be familiar with the unit circle because tomorrow we're going to do 2 activities where you are not going to have the unit circle in front of you. Okay? Now, here are some tricks to remembering the unit circle. So focus your attention up here before you pack up, okay? I have a minute and a half. I won't take that much time. If you can remember, now the ones that I have in black, I don't think you have to memorize those. I think you can figure those out just because of the radius rule. You have 3 numbers to remember. Radical 3 over 2, 1/2, and radical 2 over 2. It's just a matter of where they go. If you can remember these 3 coordinates in the first quadrant, it's just a matter of symmetry to get them placed in the other 3 quadrants and the negatives and positives. Okay? So radical 2 over 2, radical 2 over 2, that should be an easy one to remember. It's just a matter of 1/2 radical 3 over 2, which one's x, which one's y for 30 versus 60. If you can get the first quadrant figured out, you should be able to fill out everything else. Okay? Tomorrow we'll do some work with the unit circle, but please, 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 please make sure you do your homework tonight so you're at least familiar with it. All right?